solve the sine of x plus cosine of x is equal to 1. All right, so, I mean, this looks pretty interesting because there's a plus here, right? It's not a times. So we have the equals 1 on the other side. So, what's our approach here? Well, let's bring everything over to one side. Okay, we'll subtract the 1 over. You notice that this is not factorable. It's not quadratic. We have 3 different terms here, right? So there's really nothing we can do, right? Maybe we can like divide out, just like by a sine or a cosine. So, I can divide everything by sine. Okay. But it's really not going to help us, right? We get 1 plus cotangent of x is equal to cosecant of x. Right? Remember, these are not squares either, right? So this is not an identity. Okay. So, okay, that doesn't leave us anywhere. We, divided by cosine is, not going to change anything. We can't really add anything or combine these because the denominators are 1. Okay. So another algebraic method we can use is we can square both sides. Okay, so what do we mean by that? We got sine of x plus cosine of x. I'm going to square the whole left side, and then I'm going to square the whole right side. In this case, the right side is just a number. Okay, so what happens when we square this? Remember, this is sine of x plus cosine of x times the sine of x plus the cosine of x. And we got to FOIL this properly, right? We get sine squared of x plus sine x cosine of x. And we actually get the same term in the middle, so there'll be 2 of those, plus cosine squared of x. And that's just going to equal the other side, right? It's going to equal 1. Oh, wait a minute. Sine squared plus cosine squared, that's just equal to 1. So we get 2 sine of x cosine of x plus 1 is equal to 1, and hey, I can subtract the 1 to both sides here. I get 2 sine of x cosine of x is equal to 0. Oh yeah, look, this is just another double angle formula, right? 2 sine x cosine x is actually just equal to the sine of 2x. And here we should be able to solve this. Okay. Well, okay, but remember, this is called the multiple angle. In this case, the coefficient of 2 is going to change the original answer, right? So what do we know that the sine of theta, right? Where does the sine of theta equal 0? We know that sine is equal to 0 at 0 and at pi. Okay? But remember, 0 and pi do not solve this. Okay? So what we have to do is we have to sort of divide out the 2 here, right? We have to make up for that. Okay? So 2x is equal to 0 plus 2k pi. And then 2x is equal to pi plus 2k pi. And then when I divide both sides by 2, right, notice 0 divided by 2, well, yeah, that's just 0, right? So we get 0 plus k pi. And then here, when I divide by 2, I get x equals pi over 2 plus k pi. Okay? So these are going to be our solutions here. Remember, it doesn't say to only find the solutions from 0 to 2 pi. So in that case, we know that we have to find all solutions which are the coterminal angles. Okay? The reason why it's not 2k pi, the reason why we divided by 2 was because of the presence of this guy here, right? That's going to change the period of the function.